I will teach you about encapsulation and different types of access modifiers. Now, encapsulation means hiding some kind of important data and providing some kind of security to it. So basically, you can restrict access to variables and methods so that it cannot be modified unintentionally or accidentally. Now, there are two types of encapsulations in Python, public and private. So all the methods we have made so far are public. Now, in order to make a private method or private variable, you need to put two underscore right before the variable or method name. So now let's create a class of courses. So class courses, and this class will contain a public variable of name student, and this will be equal to, let's say, 55, and a private method and a private variable as well. Now, in order to make a private variable, you need to put two underscore and then the name of the variable. So let's say that it is username and it is equal to Udemy29. And now this class will contain a public method as well. So def student strength, and this method will print something out on the console screen. So we can print this is a public method, and now I will have one private method as well. So def, and now these two underscore to indicate that this is a private method. So I'm going to name this method as student username, and now I will print this is a private method. Okay, now this private variable and this private method can only be accessed within this class. It cannot be accessed outside the class. So now let's make a new class in the same module, and I'm going to name this class as test, and now we will make the instance of this class courses. So just name this instance, name the instance anything you want and put it equal to courses. And now if I access the public method, so it is student strength, you can see that we do not have any two underscore right before this method name. It means that it is a public method and we can access it, and we can access it outside the class. So now when I run it, you can see that it is accessing this method student strength and printing this thing out on the console screen. Now I can also access the private variable student, and now when I run it, you can see that it is accessing this variable. So now let's print out this thing, print, and now run it again. So see that it is accessing this public variable. If I try to access private method or variable, let's see what error it will give me. So a dot underscore, what I have named it, it is std username, and now when I run it, it will give me the error. It shows me the error, attribute error, courses object has no attribute, this thing, because it does not know anything about this method as it is kept private. In order to access private method in another class, we first make the instance like we have made right here, and then with this instance name we first call the class name with the underscore. So the name of the class is courses. So see that we have put this underscore, and then right after the underscore type dot, and then the private method, which is std username. And now when I run it, and it is still giving me an error. So let's see what it is. I think that I don't need to put this dot here, and now when I run it, So now see that it is accessing the private method as well. So now in order to access private method, we first create the instance of that class in which that private method resides, and then I type the class name, but before the class name I type this underscore, and then without having any dot I type the name of the method. Now we can access private variables in much the same way. So just remove it and type the name of the private method that you want to access. So in this case it is user name. So I think I need to print out. So print, and now run it. So you can see that it is accessing the private variable as well. So this is how we can create private variables and private methods, and you have learned how basically we can access it in Python. So that is all for this tutorial. Thank you for watching, and I will see you next time. Of object-oriented programming, and it's known as polymorphism. So you will learn about polymorphism in Python and how it is useful in this video. So in Python, polymorphism is the ability of multiple different objects derived from different classes to be used in the same way. Polymorphism is the ability of an object to take on many forms. Polymorphism in general sense refers to the property of an object being capable of existing in several different shapes or forms. In Python, polymorphism refers to different classes having methods by the same name, but these methods have the same functionality achieved differently. Now, particular behavior may be realized differently by objects of different classes. These classes are said to have the same interface owing to the same name of the methods. Now, for object-oriented programming in Python, this means that a particular object belonging to a particular class can be used in the same way as it were a different object belonging to a different class. Polymorphism allows for flexibility and loose coupling so that code can be extended and easily maintained over time. Polymorphism is an important feature of class definition in Python that is utilized when you have commonly named methods across classes or subclasses. This allows functions to use objects of any of these polymorphic classes without needing to be aware of distinctions across the classes. Polymorphism has two major applications in object-oriented programming language. The first one is that an object may provide different implementations of one of its methods depending on the type of the input parameters. Now the second one is that code written for a given type of data may be used on data with a derived type, that is, methods understand the class hierarchy of a type. Now take an example of humans. We behave differently in different situations. That is, we have the same body, but it behaves differently in different scenarios. Now same is the case with polymorphism. That is, different classes may have methods with the same name, but they behave differently on execution. Well, we will look at the example right in the next slide. So now take an example of cars. Imagine that you need to write a function that calls the move forward method on any type of cars that it is passed. Every object created from the original car class or any of the subclasses that extended should have a move forward method, even if it is being overridden to do something slightly different in some of the subclasses. This means that through polymorphism, you can write a single function that takes a car object and calls move forward method. Since all the objects instantiated from the subclasses of car are still technically car objects and have all of its original properties in some form or another. So this will work. Now you can see that we have two different classes. One class is known as peer and the other class is known as dog, but they have two same methods, that is sound, and in this class dog we have the same method sound. Now this method on execution will print different things, that is the beer will have its own sound while the dog will have its own sound. Now what we did is that we make a function make sound, and then first of all we make the objects of these classes, that is first we make the object of the beer class, and then we make the object of the dog class, and then we make a function, and then we are passing this object to this function, and then this function, depending on the object received, called the sound method. So first of all we send this object, that is beer object, to this function, and it is received here in this object animal type, and now since beer object has the information of only the beer class method, so it will call this method sound and will print this thing out on the console screen. Now similarly we send the dog object, and it will be received here in this parameter animal type, and now since we send the dog object, so the dog object has only the information of the sound which is produced by the dog class. So it is just copied here and is received here in this parameter animal type, and now this time it will call this sound method and will print this thing out on the console screen. So now coming to the advantages of polymorphism, the first advantage that we have is that method overloading allows method that performs similar or closely related function to be accessed through a common name. Now you can see that in here we are accessing both the sound method with the same object. Now this is what it is telling, that method overloading allows method that performs similar or closely related function to be accessed through a common name. That is, we are accessing basically both of these functions with the common name, that is animal type. For example, a program performs operation on an array of numbers which can be int, float, or double type. Now method overloading can be implemented on constructors, allowing different ways to initialize objects of a class. This enables you to define multiple constructors for handling different types of initializations. Now method overloading is something that method overriding allows a subclass to use all the general definition that a superclass provides and add specialized definitions through our overridden methods. Now method overriding works together with inheritance to enable code reuse of existing classes without the need of recompilation. So now let's move on to coding to see polymorphism in action. So for this, open your PyCharm, and now what I'm going to do is that first of all I'm going to make a class, and I'm going to name it as, let's say, cat. Now this cat will have a function known as, let's say, sound, and obviously self, and then it will print the sound which is produced by cat. And now in the cat class I will have one more function of name swim, and this will print cat cannot swim. Now I will have one last method in this cat class, and I'm going to name it as color, and you can say that print. Now you can say cats comes in different colors. Now I will have one more class of name, let's say duck, and it will have the same method of sound, but this sound method will print something else, and it will print basically the sound which is produced by a duck. And now we can say def swim, and we can say print duck can swim. Now I will have one last method that I also have in the cat class, and it's known as color. And now I can say print, and well, I can say duck, or you can say usually black and white. Now I'm going to make a function, and I'm going to name this function as animal properties. Well, this function is outside both of these classes, so I'm going to name it as animal properties. And this function will take an object, and now notice that this function is actually outside the class, so that is why it is not taking this object self. So it is actually taking it will actually take a parameter animal, and now through this parameter we will call these methods. So I can say animal dot sound, animal dot swim, animal dot color. Now I'm going to make the instances of the cat class and the duck class. So I'm going to name the first instance as catty and put it equal to the cat class, obviously. And then I'm going to make one more instance for the dog class, duck class, and I'm going to name it as ducky and put it equal to a built-in class duck. And now I will pass both of these instances to this function animal properties, and it will be received in this variable, in this parameter animal. So I can say animal properties, and now I'm going to pass this function catty, and now I'm going to call this function again, and now this time I will pass this object ducky. Okay, so now what I'm doing is that first of all I made two classes, and these two classes have the same method but they behave differently on execution, and then I make a function outside the class body, and then this function is actually calling the methods of these two classes. Then I make the instance of the cat class and then the duck class, and now I'm calling this method, and first of all I am passing this object catty, and it will be received in this variable animal. And now since the catty object has all the information of the cat class, so it will call the method of the cat methods of sound, swim and color, and then I will pass this ducky object, and it will be received in this variable animal. And since ducky object contains the information of only the methods that are in the ducky class, so it will go to the sound method in the duck class, and then swim method in the duck class, and similarly color method in the duck class. So now I think I can run it. So run, and it is this thing. So you can see from the output that first of all it is going to the cat class and accessing every method in the cat class, and then it is going to the duck class and accessing every method in the duck class. So this is what polymorphism is about. So let me teach this slide once again. That method overloading allows method that perform similar or closely related function to be accessed through a common name. So in here we are accessing the methods of the of both classes with the same name, and this name is animal. So with this animal method, so with this animal object, we are accessing the methods of both cat class and duck class. So this is what polymorphism is all about.